Hello, honors pre-calc students. Mr. Gazzato here. I wanted to talk about cable problem number 1. So if you read the problem, I'm just going to paraphrase it. We need to run cable along the LAN from the factory along the LAN, and then we're going to run some cable underneath the river in green to the power station. And we want to find the minimum cost. So we know the blue section is going to be 200 minus x, because this little yellow distance is x. We have a right angle there. We'll assume that's a right angle. So Pythagoras would say leg squared plus leg squared is hypotenuse squared. So the green piece is going to be 60 squared plus x squared. And if you were to simplify that, 3600 plus x squared. So what would the cost function be? The cost is going to be $25, so 25 times the square root of 3600 plus x squared, plus $20 along the LAN, so 200 minus x. If you wanted to distribute this, you could. So you could say 4,000 minus 20x is equal to 25 square root of 3600 plus x squared. So here's the cost function. So I'm going to type this in my calculator. I think on my calculator I didn't even distribute. So if I look at my y equal here, I got the cost function. I like to start at zoom standard, and I don't see anything. If you look at your function, you should recognize that the domain is 0 to 200, because 200 minus x must be positive. The distance must be positive. So in terms of the window, I do know that the x max, the most it could be, would be 2,000, or excuse me, 200. I'm going to change the scale to be maybe 50s. You don't have to change the scale. How high to go, I'm really not sure. I'm going to start at 1,000 and see what happens. And I'm going to change the scale to 100s. And let's see what happens. So I'm not seeing anything. Maybe I need to go a little higher. So I'm going to change this to 10,000. You could change it to 5,000, something that you want. I just usually add a 0. And now I can see I kind of went high enough. It sort of looks like there might be a minimum in there. I'm going to hit window, and I'm going to change the x max to 400. I do know the domain is 0 to 200, but maybe to see a better graph. And now you can see that there is a minimum somewhere in there. So G-solve on the Casio and minimum here. You got to keep pressing the arrow key until you get to the left of the minimum. Probably went a little bit too far in terms of going out to 400, but at least it gives you an idea in terms of seeing the minimum. Desmos also does a nice job of figuring that out. So I'm going to hit enter, and then I got to go to the right. Again, you got to keep hitting enter until you get to the right of the minimum. I'm going to make sure I'm clearly to the right. On the 0 to 200 scale, it might have been hard to kind of see where that minimum was. That's why I expanded the value out to 400. Again, I hit enter a little bit too much. So doing that, you can see it might be a little bit of rounding error, but I think that's probably 80,4900. So the minimum occurs at 80,4900. Okay, and I'm going to add occurs at. So technically the minimum is the 4,900. So the minimum cost is $4,900. And then how much cable was in each particular part. So we know that x is 80. So across the river, it would be the square root of 3,600 plus 80 squared. And going through the math there, I think you're going to get 100. Check my math, please. And then along the LAN, it would be 200 minus 80, or 120 meters. So if you wanted to build a factory across the river and you needed to run the cable, you would need, to minimize your costs, you would go 100 meters diagonally along that green piece, and then 120 meters along the land to minimize the cost. So hopefully that helps you on cable number 1.